Kia ora koutou. This question is from this year's Pure 3 exam, and I actually took it from the June 2023 papers. It was about the only question where I did that because I knew that a couple of you would have done those papers already. Now, I picked it because I thought it was a really good challenging vectors problem. One thing I saw when I was marking is nowhere near enough students drawing diagrams. So for me, there are two keys to doing a vectors question well. The first is to always work with column format, not IJK format. And the second is to draw something, like draw the line, draw the point, draw the angle, and carefully label things. Also, be really aware of when you're working with just a direction vector and when you need to find a position vector. So let's read through this question. We've got two lines, L and M, and we've got, this is line L, and we can see that line L has got some unknown components in those vectors A, B, and C, and then line M looks straightforward, right? So this is the vector equation of line M. Now I can't visualize those at all because they're written in IJK form. So the first thing that I'm going to do once I've read through is convert everything over to column form. Right, relative to the origin O, the position vector of the point P is this thing here, right? So that's vector OP. Given that L is perpendicular to M and that P lies on line L, find the values of the constants A, B, and C. So straight away we can draw the lines looking like this, and if this is line L, then P is here somewhere. Right, now the fact that they're perpendicular to each other means that the direction vectors of those two lines will have a scalar product that is equal to 0. So the thing that you're almost certainly going to use in the vector questions in A level is this result here. That the cosine of the angle between two vectors is given by this. And when that angle is 90 degrees, because cos of 90 degrees is 0, this collapses to being the simple result that the scalar product or dot product is equal to 0. So we often don't need to worry about the magnitudes. Okay, so let's get rid of all of that now. Okay, so we have to figure out A, B, and C. Now those 4 marks are actually quite simple. Then the next part is also okay if you take it slowly. It looks horrible because we've got this thing in here straight away. So the perpendicular from P meets line M at point Q. So I've actually already drawn the diagram that I need here. Here's point P, and this is point Q here. And then the point R lies on PQ extended with PQ to QR is equal to 2 to 3. So R is out here somewhere. Sorry, that's not 3, that's R. So my strategy in the second part is that I'm going to figure out where is this point Q, or what is the position vector OQ. And to do that, I'm going to have to figure out a value of lambda, right? Because every point on this line here has got an associated value of mu with it, right? So we're going to figure out what that value of mu is. Again, we're going to use the dot product, and then we're just going to slowly work out, well, if the ratio of PQ to QR is 2 to 3, I can see that I'm going to take this distance here, and I'm going to times it by 1.5, and I'm going to bung that onto Q, and that's how I'm going to get the position vector of R. Now I'm hoping that you guys are going to keep watching because there were a lot of small but important mistakes made in this question. So I guess what I'd like you to do if you're in my class this year is to have another go at this problem now that I've given those hints, work through it, but then please watch as I work through the whole thing. Okay, so let's start off with this first bit. What have we got? Now, this might be interrupted by the dog. It's the only problem that I foresee. Right, so quickly putting those lines into column format. The first one has got, what's it got? Let's see. So it's A, 3, B, plus lambda, C, negative 2, 4. And I'm going to write that as A plus C lambda, 3 minus 2 lambda, and B plus 4 lambda. Okay, so that's line L, and then I've got M, so we'll just get M sorted out at the same time. So the vector equation of line M is much cleaner. It's 1, 2, 3 plus mu times 2, negative 3, 1. So that's 1 plus 2 mu, 2 minus 3 mu, and 3 plus mu. Okay, so we know that L is perpendicular to M, and we know that P lies on line L. So let's have a look at what we can do already before we use the perpendicular thing. So P lies on line L, and P is equal to this. So P is equal to 4, 7, negative 2. So just looking at this, if it's on line L, that means that P fits those three, or the components of P fit those three values. And we can see that this one here hasn't got an A, B, or a C. So we're going to be able to work out lambda as a first step, and from there we'll be able to work out B, A, and C. So let's do that now. Okay, so point P, what was P? Let's see. Oh, now I haven't got the question here anymore. Okay, so OP was equal to, what did we have? 4, 7, and negative 2. And we know that that lies on line L, so we're going to have A plus C lambda, 3 minus 2 lambda, and B plus 4 lambda. So I'm going to equate these two here. 7 is equal to 3 minus 2 lambda. 4 is equal to negative 2 lambda. So we get a lambda value for point P of negative 2. I'm going to take this, and now I can work out, what can I work out next? Well, I can get B next, right? So we can say that negative 2 is equal to B plus 4 times negative 2. Negative 2 is equal to B minus 8. That gives me B is equal to negative 2 plus 8, which is 6. So that's good, but we haven't got A and C yet, and we can't get them directly here because we've got one equation with two unknown things. So the next fact that I have to use is that L is perpendicular to M. Right, so because these two vectors are perpendicular, their direction vectors are going to have a dot product of 0. So L is perpendicular to M, and the direction vectors of the two vectors are going to be C, negative 2, 4. So I'm going to put a bit more working in for this, right? So cos of theta is equal to 90 degrees. Sorry, start again. Right, so theta is equal to 90 degrees. Therefore, cos of theta is equal to 0, which means that C negative 2, 4 dot 2 negative 3, 1 is equal to 0. So that gives me 2C plus 6 plus 4 is equal to 0. 2C is equal to negative 10, giving me C is equal to negative 5. So we've got B and we've got C. The last thing that we're going to do is work out A. Right, so we're going to work out A using this equation. 4 is equal to A plus C times lambda. So 4 is equal to A plus C lambda. 4 is equal to A plus negative 5 times negative 2. So 4 take away 10 is A, and A is equal to negative 6. So let's just check that we've got A, B, and C. There's A, there's B, we've got lambda along the way, and C is equal to negative 5. Okay, so let's go back to the question and check that we've done that first part. Yep, we've done the first 4 marks, we've got A, B, and C. Now we're going to take a look at the second part, so I'm going to erase all of this. The perpendicular from P meets line M at Q. Now I've talked about this a little bit already, and I drew a diagram earlier that worked for both parts of the question. So I'm going to draw a diagram again now. So here's line L, and here's line M. And we know that P is on L, and I've drawn this so that P is sitting out here, so P is on L, and we know that it is, line L is perpendicular to M. Right, so we know that the position vector OP is equal to 4, negative 1, 2. Sorry, that's not right. 4, 7, negative 2. Let me just fix that up. 4, 7, negative 2. We have to figure out what is Q. Right, well, the first thing to do is to say, how do I get from P to Q? So the vector from P to Q is OQ minus OP. And Q is some point on that line. Right, so let's just work out what's OQ. Well, OQ is on line M. So it's going to have this position vector, 1, 2, 3, plus mu times 2, negative 3, and 1. Okay, let's just go back and see exactly where that came from. All right, so that's from in here, all right? It's that question there. So we're not using any of the stuff about the A, B, and C. So what can we say now? Well, we've got OP and we've got OQ. So we just carefully work out, how do I get from P to Q? So P to Q is from O to Q, take away O to P. So we have 1 plus 2 mu minus 4, 2 minus 3 mu minus 7, 3 plus mu plus 2, which gives me negative 3 plus 2 mu, negative 5 minus 3 mu, and 5 plus mu. So that's PQ. Now, what I have to use next is the dot product. What am I going to do here? Well, we know that PQ is perpendicular to M, so this angle here is 90 degrees. The direction vector of this line is given to us by 2, negative 3, 1. Right, so that's the direction that we're going in along here. So cos of theta is equal to 0. So negative 3 plus 2 mu. So this vector here, PQ dot what? 2, negative 3, 1 has to equal 0. We've got a linear equation now, so we get negative 6 plus 4 mu plus 15 plus 9 mu plus 5 plus mu is equal to 0. What do these add up to? I've got 9 plus 5, so 14 plus 14 mu is equal to 0. That gives me a value of mu of negative 1. All right, so then the last step that I've got to do is that I can figure out a couple of things. I can now figure out where Q is sitting on that line. So let's do that first. So OQ is equal to, let me just go up to it and see. So OQ is equal to 1, 2, 3 plus negative 1 times 2, negative 3, 1. That gives me 1 minus 2, 2 plus 3, and 3 minus 1, which is negative 1, 5, and 2. All right, I'm just checking that that's what I got when I did this earlier. Yep, that looks right. It's always worth checking back in the vectors problems. So that point is found, and that means that I can get the vector from P to Q. And then I'm going to want to take it out the other side and work out where R is sitting, right? So we've done all the hard work in this question now. We just have to be careful not to muck up. Happily, we've already worked out that this is vector PQ. So PQ from P to Q is going to be negative 3 minus 2, negative 5 plus 3, and 5 minus 1. All right, so just watch how that diagram is helping me. Here's P, here's Q, and R is out here. So that distance, the ratio is 2 to 3. So we're going to take this and we're going to times this by 1.5. So QR, get from Q to R, we keep going, but we go a bit further, right? So